again, it's set before this, solve for theta, and we're solving between 0 and 2 pi. And all the other questions are on YouTube already. You can catch up. So it's quadratic equation. So your options are, you make it equal to 0, and now we can either factor or use the quadratic formula. And the quadratic formula is on your formula sheet. So this might be one, I'm going to tell you it does factor, but sometimes with that leading number of 6, people get stuck on it, and they might want to use the quadratic formula. So for this one, I'm going to show you factoring, and then I'm going to do another one that can't be factored, that you would have to use the quadratic formula on your exam if that came up. Okay? And they put the quadratic formula back on the formula sheet just so they could ask those questions. So they've been asking them a fair bit as a result. Now, if we can multiply this out, your first ones would have to be multiplied to give you 6 sine squared. Your last ones would have to multiply to give you a 1. And your outside and inside would have to give you sine. Now, as students, we typically start with the first one because it's first. But you don't need to. Like, the first one's kind of hard because I don't know if it's going to be 3 and 2 or 6 and 1. So I'm like a little bit of a dilemma. So instead, I look at the last one and go, oh, the last one's super easy. It's a 1. It has to be 1 and 1. That's going to be nice because now when I start to think about my first ones, either 6 and 1 or 3 and 2, can you see that 6 and 1 would give an outside of 6, inside of 1? And that will never be plus 1, adding or subtracting. 6 plus 1 never equals 1. But if I do 3 and 2, now my outside is 3, my inside is 2. I need a plus 1. So I would want my outside to be plus 3 and my inside to subtract 2. Give me plus 1. Double check, do I still get the minus 1? Yes. Now that I factored it, then this is going to be, if this is 0, this is 1/3. If this is 0, this is 1/2. And the 1/2 is on our pi plate. So this side we can do without a calculator, right? The one that I memorized is sine of pi over 6. Sine of pi over 6 is half, so I know my family is pi over 6. And positive means we would look in quadrant 1 and quadrant 2. Now 1/3 is not on our pi plate. So this would be a calculator question, and this side would be required to use your calculator. And you would do just what you would do in grade 11. Oh, this one's supposed to be, yes, thank you for noticing. That's supposed to be -1/2, so that's going to change it to quadrants. 3, 5 or 6 family still. Are quadrants 3 and 4. Now 1/3 is not on your pi plate. So you have to solve this like grade 11. First of all, I'm going to do it as if I was in grade 11. If I was solving for theta here in grade 11, I'm not going to write anything down. I'm just going to show you what I would do on my calculator. I would have gone to my calculator, and my calculator, because I'm in grade 11, is in degrees. And I would have gone sine inverse of 1 divided by 3, and that would give me my reference angle, 19.4 degrees. Well, and they like 3 decimal places, so 19.471 degrees would be my reference angle. And then, because sine is positive, I would use my CAST rule and say one answer is in quadrant 1, and the other answer I'd have to add 180 degrees and get 199.47. No, I'd have to take 180 degrees and subtract my reference angle, because it would be in quadrant 2, and I get 160.5 degrees. Is that a good review of grade 11? Okay. The only difference now in grade 12 is this question wasn't in degrees. It was in radians. but you do everything else identical. So you go to your calculator, but now on your mode button, you change it to radians. And you start by doing sine inverse of 1/3 just like before, but now instead of giving me an answer in degrees, it gives me an answer in radians, 0.340. That's my reference angle. I can write that down. And I actually sometimes I put like a dot, dot, dot here, saying I'm not rounding early, because rounding early could result in your final answer being slightly off, which is an E6 error, rounding error. So I put the dot, dot, dot saying I'm going to keep it all. Then, when I put my answer in quadrant 1, rounded to 3 decimal places, will be 0.340. And in quadrant 2, instead of doing 180 minus my reference angle, does it make sense that I'm going to use pi minus my reference angle? And I get 2.802.
Does this unit work 3 decimal places?
The whole course, whenever you use a calculator, 3 decimal places all the time. It's kind of, I had a little beef with the exam, because the exam has a little tiny instructions right at the beginning to 3 decimal places, but then they don't tell you in questions. And if you don't do 3 decimal places after they didn't tell you in the question, they take off around.
So it's 3 unless stated otherwise.
3 unless stated otherwise. So this question, we needed to use our calculator for part of it because it wasn't on our pipeline. It's a very, very popular on the final exam. You only have 5 or 6 questions that require a calculator. Very popular to put one of these ones. Okay? If they want you to use the quadratic formula, so I'm going to add a question F. Maybe a room at the bottom of the page somewhere. And I purposely made one up that was not factorable. So on your formula sheet, you have the quadratic formula. The quadratic formula looks like this. And it is, and the reason I write that top part in purple, you have your formula sheet here, I don't think they give you that part. They just give you the formula. Oh no, they do give you. Okay, I'll change it to blue. Nice. Here we go. They give you all of this. For ax squared plus bx plus c equals 0, this is the answer for x. Okay? First thing I want you to notice that it's for x squared, that you have x equal. Do we have x squared? No. We have tan squared. So the first thing that we're going to do when we solve this and plug things into the formula, instead of x equals, we will write tan of theta equals negative b, negative 5, plus or minus square root. B squared would be 25 minus 4, and a is 2, and c is negative 1 over 2 times a. I'm just going to simplify this as much as I can. Negative 5 plus or minus 25 plus 8, 33 over 4. So first of all, just plugging things into the quadratic formula. This technically, with the plus or minus, gives us 2 possibilities for tan. I'm going to write them out separately. Negative 5 plus square root of 33 over 4, and tan of theta equals negative 5 minus the square root of 33 over 4. sometimes the problem with these fractions is mental math-wise, you can't tell right away, are they positive or are they negative? I can tell this one's negative pretty easily. This one's not so easy to tell that it's positive, okay? So one of the things you could do is you could go to your calculator and we could just type them in, -5 plus the square root of 33 over 4, and it's 0.186. And this one, -2.686. This is going to be important for figuring out my reference angles and solving. Okay? Obviously, these values are not on your unit circle. That's never your tangent value. So we have to solve it the same way we would solve in grade 11. Find a reference angle, then think of our CAST rule, and write our solution. So how do I find my reference angle? I would go tan inverse, and I'm going to do the positive one first. Did you know you can move up and down and just highlight things so you don't have to retype them? That is super nice. So if I go tan inverse of this, I get a reference angle of 0.184. So my reference angle, 0.184, dot, dot, dot. This one is positive. According to your CAST rule, tangent is positive in quadrant 1 and quadrant 3. So in quadrant 1, it will 0 to 3 decimal places will be 0.184. I'm going to double check if that's rounded, yes. And then in quadrant 3, I would go pi plus this answer and get 3.325, or 3.326 when rounded. Do you remember from grade 11 when you're finding a reference angle and the answer is negative? You put in the positive value. So if I go second tan inverse and I wanted to steal this number from before, the problem with that number is it's negative. So one of the things that you could do on a calculator is just multiply by a -1, that'll make it positive. Or you could type in all of those numbers without the negative sign. But when finding a reference angle, the inside always has to be positive. This is especially dangerous if you do cosine. Not as dangerous for sine and tangent, because if you did, watch, if I accidentally did tangent without the negative of that same number, I get the same thing but negative. And you're like, ooh, I'll just ignore the negative. Kind of works, but it's really bad with cosine. Cosine gives you a totally wrong number, and you won't even notice you're doing math wrong. So it's very important to always get in the habit of finding your reference angle by doing tan inverse of the positive value. Then another nice thing you can do with your calculator. So I'm going to just pretend I did all my math right, and I had my reference angle. Right above your on button is a store button. This can be really helpful when you find your reference angle. And I'm going to just take that answer and I'm going to store it, and I just like to use the X button. Just temporarily stores it as X. Doesn't affect your graphs, doesn't affect anything. But what's really nice about this is tan is negative in quadrant 2, so you would want to do pi minus your reference angle, but now that I've stored it, I can just go pi minus X, 1.927. And then when I want to find quadrant 4, I could just go 2 pi minus x. Especially nice when you have to use your reference angle twice, 5.069. So it's possible you could get questions that require you to use your calculator and the quadratic formula. This would definitely be on a calculator part of the final exam if it came up.